All right, friends, today we are going to review factoring a quadratic. Hopefully this sounds familiar from Math 1. So we're going to start with x squared minus 5x plus 6. And I'm going to show you this with algebra tiles first, just so you remember visually what we're doing. These red rectangles are going to represent my negative 5x. And then I have plus 6. 3, 4, 5, 6. Okay. So ultimately my goal with these is to create a rectangle, and I'm going to find the length and the width of this rectangle. So my x squared terms is always going to be in the top left corner, and my singles are always going to be in the bottom right corner. So sometimes if you're thinking of this visually, it's easiest to manipulate those x squared and and single digit units first, because now my goal is to fit these x's into this rectangle. So now I've created a rectangle where each of my x blocks line up with a single digit block in both directions. So I'm going to look at what this looks like in the box, and we'll talk about what those factors would be. So now this box is similar to what we did when we were completing the square. However, my corner boxes are not going to be identical necessarily in this case. So this would be x squared and this would be 6. And so I've split up negative 5 so that we mimic or mirror how these 6 are set up here in the corner. So I have negative 3x and negative 2x. So now to get from the inside of the box out, I'm going to look for my common factors. So between x squared and negative 3x, they have x in common. Between negative 2x and 6, they have a 2 in common. X squared and negative 2x have an x, and negative 3x and 6 have 3 in common. Now, I have to go back and double check. I'm not going to make x's negative. If I'm going to make anything negative, it's going to be these constants. So in order to get negative 3x here, this 3 would have to be negative. And in order to get negative 2x, this 2 would have to be negative. And then when I multiply them, I'll have a positive 6. So my factored form would be x minus 3 times x minus 2. So this would be the length and the width of the rectangle that has the area x squared minus 5x plus 6. So let's try another one. And I'm going to do this time without using the algebra tiles. So I have x squared minus 3x minus 18. So I have x squared and negative 18. And my goal is to break down negative 18 so that when I multiply these two numbers together, I get negative 18. But when I add them together, I get negative 3. And actually, I'm going to rearrange this just a little bit. So when I multiply, I want to get negative 18. But when I add, I want to get negative 3. So my factors of negative 18, I have negative 9 times 2, negative 6 times 3, and then I could do these in reverse. So I could have negative 2 times 9 and negative 3 times 6. So what I'm going to do now is I'm going to add these two factors together because these are the numbers that are going to go in these corner boxes with x. So if I add them together and they make negative 3, then I know when I combine these two corners, they would create negative 3x. So negative 9 plus 2 gives me negative 7. That's not going to work. Negative 6 plus 3 gives me negative 3. So I don't even have to look any farther. Those are going to be my corner boxes with x. So now if I was to simplify this, it would be x squared, negative 6x plus 3x gives me negative 3x, and then I'd have minus 18. So now I'm at the point where I can look at my common factors. This will be x in common on both corners here. These have a 3 in common, and these are both negative, so I can pull out a negative 6 from both of those terms. So this would be x minus 6 and x plus 3. And if you put x plus 3 first and x minus 6 second, that's totally fine. It's the exact same thing because multiplication works in either direction. All right, so for this one, I actually am going to get my algebra tiles back out because this will be the first time we've seen something with 3x squareds. Now remember, I want to create this as a rectangle. So I wouldn't put the 3x squared up like this or over here because that's not going to create a rectangle. That's going to create some funky shape that we don't have. And I have negative 5x again. And again, I put this 2 here first to help you visualize how to split up these 5x's. So I can attach a negative x to each of these. So there's 3, and then 4, 5. So this is what it would look like visually. Now I realize you're not going to always have algebra tiles. So I'm going to show you how to get this visual representation without actually having algebra tiles. So I have 3x squared here and 2 here. And somehow I have to use those two values to get me a number that's going to get me negative 5. What we're going to do is take the 3 and the 2, and I'm going to multiply them together. So that's going to give me a value of 6. So now I'm trying to find factors of 6 that when I add them together, I get negative 5. So since I'm trying to add to make a negative, but multiply to get a positive, I have to make both of my factors negative. So I would have negative 6 times negative 1, negative 3 times negative 2. So those are my only factors of 6. Well, negative 6 and negative 1 would give me negative 7, but negative 3 and negative 2 would give me negative 5. So this would be a negative 3x and a negative 2x. So here, if I'm looking at common factors, 3x squared and negative 3x have a 3x in common. 2 and negative 2x have 2 in common. Here, I only have x in common. And here, they have nothing in common, so we write that as just a 1. So now if I look at those pieces on the outside and multiply into the center, 3x times x gives me 3x squared. X times 2 gives me 2x, but that's not what I want, so this will have to be negative. 3x times 1 gives me 3x, but I want it to be negative, so this has to be a negative 1. And then negative 2 times negative 1 gives me positive 2. So this will be x minus 1 and 3x minus 2. And if this isn't the way that you learned to factor, that's totally fine. You can do factor by grouping if you prefer. But because we did completing the square using this method, this is what I'm going to use just to help your brain. So let's do one more of these. Actually, I'm going to do this one. So here, you'll notice that each of these are an even number. Before I can do anything else on this question, I have to factor out that common factor. Now this is where it's a little bit different than completing the square because I'm using all three terms when I go to the box. In completing the square, we only used our first two terms with the x's. So we only factored out the common factor from those two values. But because I'm using all three terms, I'm factoring the 2 out of every single term. So 2 times x squared would get me 2x squared. 2 times 8x would get me 16x. And 2 times negative 16 would get me negative 32. So one thing we're going to have in our final factorization is that coefficient of 2 out in front. And now our goal is to figure out how to break down x squared plus 8x minus 16 to get these two values here. This needs to be a plus. So sorry. Make that a plus. My bad. It will not be pretty the other way. Won't work the other way. All right. So now I have to multiply to get 16 and add to get 8. Well, the only way that works is by doing 4 times 4. Because 4 times 4 gives me 16 and 4 plus 4 gives me 8. So we're going to go over to the box. Now this is one of these special cases that we talked about before where my corner boxes are actually the same. So my factors are going to be the same. So instead of writing this as 2 factors, this is one of those special cases where it actually goes into vertex form. So our vertex form and our factored form are the same. Now this wouldn't work if this was negative because I can't multiply to make negative 16 and add to make positive 8. So a few things to remember when we're factoring. The first thing I have to do is always look for common factors. If there is a common factor, I take that out of all three terms. So let's look at this one. So 8, 25, and 3 don't have a common factor. So I'm going to look at 8 times 3. So that gives me 24. I did not leave myself enough room. So I'm multiplying to make 24 and adding to make negative 25. Well, since this is negative, both of these values have to be negative. And I'm going to start with negative 8 times negative 3 because that's what we started with here. Well, 8 and 3 definitely does not make 24. That makes negative 11. So that's no good. So let's think of some other values that multiply to 24. Well, 6 and 4 we know definitely wouldn't make 25. In this case, if these numbers are super close together, what I might want to try is the number multiplied by 1. And if I add those together, boom, boom, we have a winner. All right, so we're going to go to the box. I have 8x squared and 3. And then I'll have negative 24x and negative x. All right, x and 8x squared, they only have x in common. 8x squared and 24x, I can take x out of both of them, and I can also take 8 out of both of them. Here, these only have a 1 in common because there's nothing else. That will have to be negative in order to make x negative. Here I have a 3 in common, which will have to be negative as well. So if I double check, 8x times x gives me 8x squared. 8x times negative 3 gives us negative 4x. x times negative 1 gives us negative x, and negative 3 times negative 1 gives us positive 3. So I'll have 8x minus 1 times x minus 3. All right, some more special cases. This does not have a constant. So since this doesn't have a constant, I'm not going to use the box. What I'm going to look at, and I'm going to rewrite this so I have a little bit more space. I'm going to look at how each of these factor out and if there's anything they have in common. Well, they're both even, so I know for a fact I can divide a 2 out of both of them. I can also divide x out of both of them. And then let's see what that would leave us with. So here, if I divide 8 by 2, I'm left with 4. And I would need an x to get me back to x squared. If I divide 2 out of negative 18, I'm left with negative 9. And then the x is taken care of here. So since 2x can be factored out of both of them, that's going to be my coefficient outside of the parentheses. And then the piece that's left over from both of those is going to go inside. Now, if I wanted to double check, I can distribute the 2x back to each of these pieces. 2x times 4x gives me 8x squared. 2x times negative 9 gives me negative 18. And lastly, if I don't have a b term, the first thing we need to look for is if those values are perfect squares. If they are, we're going to do something similar to what we did on our last problem. However, I'm going to look at my perfect square within this. So 25, the square root of 25 is 5. And the square root of x squared is x. So 5x times 5x gets me back to 25x squared. 4 is 2 times 2, but one of them has to be negative. So this factorization actually uses the perfect squares to create our factorization. And I'm going to show you what this would look like in the box really quick. So this would be 25x squared, and this would be negative 4. So this would be 5x and 5x, and I know this would be 2 and negative 2. The reason there's no b term is these corner boxes are identical, but they're the opposite sign of each other, so these actually create 0. So anytime it's a perfect square, you do not have to use the box method because I know that those two corner boxes will create 0.